we want to make sure that you understand what you're doing before we send you out to do an assignment that is graded. So in this, we are going to be using the periodic table to answer the following questions. You'll notice this periodic table does not actually have elements on it. It looks a little bit different. But what are some things you notice that look the same? What does this one have? Emily?
So it has the periods, which go left to right, and it also has the groups.
It has the periods numbered and it has groups. Great, so instead of chemical elements, we do have some random letters up here, but that's okay because that's what our answers are going to be. All right? So our first question, which elements have the same number of electrons in the outer shell? Is that periods or groups? When we're looking at the number of electrons in the outer shell.
Groups.
That's groups. So what two letters here are in the same group? A and L. Good. So that's going to be your answer for number 1. And number 2 would actually have been if my next question that I kind of want to ask you anyways. What are those electrons in that outer shell called? Those are the valence electrons. That's right. So A and L would have the same number of valence electrons because they're in the same group. What group are they in?
One.
Group 1. So how many valence electrons would they have?
One.
1. Good. Now wait a second. Look at question 3. Which elements are in the same group? A and L.
Oh.
We're still talking about groups here, okay? So if you are stuck, or if you're at home and you're stuck, looking at the notes that we did over yesterday and today, going back and reviewing groups, that's what those questions are about. Number 4 asks, which elements are in the same period?
B and P.
B and P, good. What period are they in?
5.
Period 5, nice. Sorry. All right. So using this periodic table, and you might want to use the periodic table in your notes or the one that we colored in as we took notes yesterday and today. Which elements or element would be considered a metal? So look at this chart. Look at your periodic table that maybe you had on our notes. Which of these would be a metal?
B. A.
A, what else?
B, P, L.
Everything.
Yes, you can write them in any order. I probably would have done A and then L first just because they're in the same group. Would M be considered a metal?
No.
No, that would be a
Non-metal.
non-metal. Nice. Good job, you guys. I'm going to slide this up a bit so we can go to questions 6, 7, and 8. Question 6 says, if the atomic number of element M is 5, what would be the number of A? So let's look at this. If M is 5, it's here at the end. A is the first one on the next period.
B, 3.
Mark. So we have 5, and then we go to the next period, so it would be
6.
6.
I was looking at the wrong.
Now, on the real periodic table, you guys were right. The first element of the second period on the real periodic table, the atomic number is 3. But in this case, if this is 5, then this would be 6. I don't know quite why they made it different, except to see if you understood that the first one on the next row down is the next number. But that's what they did. And that could show up on your test next week. So, we're practicing. How many valence electrons does element L have? How do you know, Emily?
Oh, because it's in the first group.
It's in the first group, so it has 1 valence electron. how many how many electron shells does element M have? So for shells, do we look at groups or periods?
Period.
Periods. So element M is in period 1, so it has one electron shell. You guys are getting good at this. It really is simple once you understand kind of how to look at the periodic table. It stops being quite so crazy confusing. All right, back up to the top here. This is where we were talking about reactivity yesterday. Which element would be more reactive? A or M?
It'd be A.
A.
So I hear A and I hear M, so let's hear some arguments for that. Why do you say A?
I say A because it's further down the periodic table than M.
Okay,
S.
why are we saying M? Do I have someone that wants to argue for M? Okay, so yesterday we learned that reactivity goes from top to bottom, but we also learned that reactivity goes from
Right to left.
right to left. So A is further down the periodic table than M, but it is also further to the left. So yes, A is definitely more reactive than M. In both ways, down and over. You can write it anywhere you want, but somewhere in the same period as A, you need to write the letter C. So do I need to write it in 1, or do I need to write it going across in 2? Across in 2, because that's the period. So I'm gonna put mine here, you can put yours anywhere across that line, would be correct. As long as you stay in period 2. I'm gonna put a little check mark here so that it doesn't look blank and I think we skipped it. We're gonna write a D in the same group as M. So where could I write a D on my
Right.
periodic table?
Right under M.
Could do it right under M, yep. Or anywhere in group 10, absolutely. I'll put it right under M, that was what was recommended. Our next one makes you think a little bit harder. Write an F on the table so it has similar properties with P. Is it groups that have similar properties or periods that have similar properties? Groups. So where do I need to write my F on my periodic table?
Above.
And either one of these above the P, and I'll do it right above, but in either one of those, as long as it's in group 7. And now I have actually a couple of answers I could put for question 13. It says, which 2 elements have similar properties? So
M
I
and
have
D.
M or D, I heard someone say, yep,
B or P.
or
F or P.
B or P.
F
B.
and P, or
A and L.
A and L, because those are in the same group, which means they have similar properties. You only need to write one down if you want. You can write them all, but you only need to write one. 14 says to write the H on the table so that it is more reactive than B. So how am I going to make H more reactive than B? Hayden?
There's a spot on the most left and lower spot. and
The
that's
bottom
most
left one.
reactive element.
This is the most reactive element, so I can put it here. Is there anywhere else I could put the H? Serenity, you also had raised your hand. Is there anywhere else I could have put the H? Where? In these other 2 boxes, that's right. So anywhere in these 3 boxes would have been a place that we could have put H to make it more reactive than B. Hayden decided to put it in the most reactive spot on the table. I'm with you. I like it. Finally, we are going to write a J on the table so that it is less reactive than L. So here's L. There's really only one one spot I can't put it. And I already put an H there, right? So I can put my J pretty much anywhere else on the table. I probably wouldn't wanna do right here,
And that's still pretty good.
cause that's still pretty reactive, cause it's on the bottom, but probably anywhere other than that, anywhere I wanted, I could put I'll put it here.
in the right.
That for group is totally blank, we'll put it there. You can put yours wherever you want, as long as it's not here, cause this is about equivalent and reaction. And here's a little iffy, but anywhere else you can put J would be less reactive than L. Alright, so tomorrow, you are going to have an assignment that is either online that you are going to need to download, complete, and submit, or if you are here right now, you can pick up a paper copy